My name is Safari Jacques. I am one who want to explain you more about the study function. So let's start by this function, which is equal to f of x equal to x square negative 4 over x square negative 1. Step 1, we must find the domain of definition of this function, where nx over dx, where dx is differ from 0. So x square negative 1, as we know that it is the dx is differ from 0, and x will be equal to the square root of 1. The square root of number will have two number, one negative or another positive. So as we see, the domain of definition will be equal to the set of real number except negative 1 and positive 1. Finding if the function is even or odd. The function will be even when f of x is equal to f of negative x. By proof it, x square x times negative x negative 4 over negative x times negative x negative 1 is equal to the f of x. As we see, our function is even. When we see the function is even, we doesn't find where the function is odd, because the function is even doesn't be at the same time even or odd. For finding the possible asymptote for this function, we must first find for vertical asymptote, where the vertical asymptote is equal to nx over dx, nx over dx, nx over dx, where dx is differ from 0, and we find the value of x1 and the value of x2. As we have seen above, the value of x1 is equal to 1, or value of x2 is equal to negative 1. So for horizontal asymptote, we must know that the limit x approach to infinity of that value of x, f of x we have, is the equation we must use in order to find if the equation have horizontal asymptote. As we see, we take the equation or variable which has the maximum power. As we still have x square over x square, this will be to infinity over infinity, and it means that it is in determinational form. We take that x square over x square negative x square over x square also will be equal to 1. So if we have horizontal asymptote, it means that there is no oblique asymptote. For finding the first derivative of this function, we must use this formula. I forgot to write this formula, but this formula, it is known as v x v derivative of v times u without derivative negative u derivative times v without derivative over u square. It is the how to find the derivative of the function. So let's, after finding the first derivative for the following, for this equation, we must find the intercept of our function. So for x-intercept, it is where y is equal to 0. For y-intercept, it is when the x is equal to 0. So as we see here, we start for y-intercept where x will be equals to 0, and we have a negative 4 over negative 1. Y-intercept will be equal to 4, and x-intercept we have y will be equal to 0. As you see this function, y is equal to 0, y is equal to 0, and we find for x, as you see, we have seen the x1 and the x2 will be equal to the square root of 4, that will be equal to 2 and negative 2. And finding the point in order to draw the graph above. So the point we will see on the table that will be animated after finding its point. So I invite you anymore to join my presentation about how to solve a different equation with example, because example, making the more example, it make someone to be perfect in anything. So let's we see this table that show how this point, I see it is located. As you see, it is a perfect table that show the how our graph will be presented, and I think we have seen more. So after seeing this more, firstly we must go to see how this data we have, how it is presented on the graph. So this data will be look like this. So you will see how this data it is presented on this graph. You see the x-intercept, y-intercept, and how we draw where the line pass and curve. So as you see, this is the perfect graph which show how we present this step I have told you on the title, and see how it is be drawn. So thank you for watching this video. In next session we must see about how to find the row distribution. So we must continue on structure member analysis of loading. So we must see how to find the reaction support on uniform distributed load. Thank you for watching this video. I like you more. So have you the nice day, nice night. So thank you.